Thank you. Well, arguably one of the greatest successes of the last century was in fact the increased longevity that we observed, particularly within the developed countries. With the advent of antibiotics and the increased use of vaccination, the incidence of death by infectious microorganisms decreased significantly. And as a direct consequence of that, in many of the developed countries, particularly here in Europe, we now have more people who are retired than we do children at school. And that is a massive success, of course, of the whole process of medication. But of course, one of the major implications that has is in the medical arena, and many of the rising tide of degenerative diseases that we're likely to see as a result. Currently, 125 million Americans suffer from chronic or degenerative diseases, and their treatment consumes 78% of the entire healthcare budget of the United States. And that is, of course, entirely unsustainable in the future. But there is one glimmer of hope on the horizon, because many of these different degenerative diseases could be relatively easily treated by replacing just a single cell type or a single tissue which has become compromised through aging. And it is, of course, for that reason that so much interest has focused on stem cells as a potential source of those cells that we may one day use to rejuvenate tissues. Now, stem cells are, of course, the very strand of youth deposited in each and every one of our tissues. Even the brain, in fact, is now known to harbour these neural stem cells that give rise both to the neurons and also all the structural elements of the brain, and also the entire nervous system. And importantly, these can be taken and can be cultured in vitro, which makes them amenable, in fact, to use within the clinic. So only last year, the trachea from a woman that was diseased through tuberculosis was replaced by an entirely new trachea, which had been generated using her own mesenchymal stem cells. In fact, doctors were able to take the trachea of a cadaveric donor, to then strip it of all of its own cellular components, and then to seed it with cells taken directly from the patient themselves, the mesenchymal stem cells of the bone marrow. And in fact, when they seeded it, they were able to reconstruct this entire new trachea, which of course then had the functionality and the identity of the individual themselves. But these so-called adult stem cells do have important limitations. They can, for instance, only generate cell types from the tissue in which they reside, not cell types or components from more distantly related tissues. But if we transform ourselves back in the history of a human being, back to the early blastocyst, the situation is actually very different, because at this stage we have an inner cell mass stained here in red, which gives rise to the embryo and the entire fetus. Each and every one of these cells is able to give rise to the 200 or so cell types that make up the mammalian body. And these can be extracted from blastocysts that are surplus to requirements from IVF clinics and maintained in vitro as lines of embryonic stem cells. And it was, in fact, the isolation of these cells 10 years ago which signaled the birth, if you like, of regenerative medicine. And importantly, these cells retain their pluripotency in vitro. They can be directed to differentiate into a whole range of different cell types of obvious therapeutic potential, such as dopaminergic neurons, which are lost during Parkinson's disease, and also just spontaneously beating cardiac muscle. And of course, these cell types have been used in a number of different important clinical models of human disease with an enormous amount of success. So in fact, dopaminergic neurons have been used to treat monkeys that are suffering from Parkinson's disease. We've been able to use insulin-secreting cells to have an impact on diabetes in mice, and even those beating cardiomyocytes are able to reverse some of the process of myocardial infarction. And of course, the hope is that one day we may be able to use that very same approach to treat a whole range of different diseases in the human as well. And only last week, in fact, the FDA was able to approve the first ever clinical trial of human embryonic stem cells for the treatment of spinal cord injury by Geron Corporation. But nevertheless, as with all of the reproductive technologies, stem cell biology has had its own controversies. And of course, it raises an enormous number of very important ethical questions, which are sometimes very profound because they touch at what it really means to be truly human. But although it has in fact eclipsed some of the successes of regenerative medicine, we are now able, using new technology, to take cells from any patient and to reprogram those back to a pluripotent state, from which any cell type required by the patient for the treatment of disease can in fact be differentiated. And these so-called induced pluripotent stem cells can be generated without either creating or destroying human embryos. And so at the beginning of the 21st century, we are poised on the cusp of a revolution in regenerative medicine. And the challenge before us is to try and balance the obvious opportunities that provides with some of the risks, both scientific and sociological. Thank you.